11-6 is called segment relationships in circles. And so the first theorem that we're going to look at is called the chord product theorem. So the chord product theorem is written out on that little sheet for you if you want to read it, but we're just going to draw a picture. But it basically says this: if two chords intersect in the interior of a circle, then the products of the lengths of the segments of the chords are equal. Okay? So if you have a circle, and inside of it you draw two chords. Chords basically just have their endpoints on a circle. So you have one here, come over here, and another one over here, going over here. They don't necessarily go through the center. They're not necessarily diameters, but they are still going to have some sort of special relationship. So we'll call this one A to B, this one C to D, and then they're going to intersect right here at E. Okay? This theorem basically says that when they intersect like that, it breaks them each into two pieces. You see that? So you have this piece, and then you have this piece and this piece. So the theorem says that if you multiply those two pieces together from one of the chords, it's going to be equal to the two pieces of the other chord multiplied together. So if you take AE and you multiply it times EB, it's going to be equal to CE times ED. This is a C over here. There we go. Fix that. Kind of looked like an O. All right. So let's try it with some numbers. All right. So example number 1, we're going to start with the circle. We're going to do a chord over here to here. We'll call this one E, F, and then we'll do one up here, down to here. We'll call this one G, H, and so they're going to intersect right here at I. Let me give you some values here. From G to I is going to be 14 inches, and from F to I is going to be 7 inches, and from I to E is going to be 10 inches. So we're going to find the measure of the one that's missing, right? HI. Does it keep going blurry and then going and focusing when you guys are looking at it? Yeah, okay. All right, so I'm going to put an X there, right? Just to help me with figuring it out. So the theorem up above that we just wrote means that if you take the two pieces of one of the chords, it'll be equal to the two pieces of the other chord multiplied together. I prefer my variable on the left, so I'm going to do this one first. I'm going to do 14 times X and set that equal to the other chord, which is this much is 7 and this much is 10, so 7 times 10. And then I'm just going to simplify. So this is 14x equal to 70. Divide both sides by 14. Punch it in the calculator. I got 5. Okay. X is equal to 5. But they want us to find, oh, that is HI. We got HI, but what if they ask us to find the length of the whole thing? What if they say, what is GH? Anybody know how I'd get GH? You should add it, right? So 14 plus 5 is going to be equal to 19 inches. Or they might ask you FE. That one, the numbers are already there. It's 7 and 10, so 17 inches. Notice that they're not necessarily congruent, but because they're the chords within the same circle, their product. Product means when you multiply them, the product of their pieces is equal to each other. All right? Any questions on example number 1? All right. I'm going to move this up. You'll see it in just a second. All right. The next theorem is called the secant product theorem. So it's going to be similar, right? Because we're still talking about product. But this time, instead of being chord, it's going to be secant. So secants look a little bit different, right? So if you start with a circle, which is what you're always going to start with in this chapter, here's what the secant product theorem says. It says, if two secants intersect in the exterior of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the length of the other secant segments and its external segment. So, in short, it's the whole length of the secant times the outside, which you'll see in just a second, is going to be equal to the whole of the other secant times the outside. So a secant starts on the circle and passes all the way through to the outside. So that's a secant right there. We'll call this one A, B, E. That's our first secant. The whole thing would be from here to here, and the outside would just be from here to here, because that's the part that's on the outside of the circle. So when we draw another one, we'll call this one C, D, comes over to E. Okay? So now we've got two. So let's start with the top one. The top one, the whole thing would be AE times the outside, which is BE. That's going to be equal to the other secant, the whole thing, which is CE, times just the outside, which is DE. Okay? So let's try one with some numbers. This will be example number 2. Start with the circle, and we're going to draw two secants intersecting here and here, here and here, and here are your measurements. We've got 8 centimeters right here, we've got 9 centimeters right here, and 7 centimeters right here. Okay. So this theorem's slightly different. We need the length of the whole thing, right? So on the bottom one, that's pretty easy, right? 9 centimeters plus 7 centimeters is how many centimeters? 16 centimeters is the whole, okay? So we've got that much. But here on the top secant, we're missing this piece right here. So I'm going to put a little X there because that's what we're missing. But if we were to find the length of the whole thing, it would be this plus this, right? It would be X plus 8. Does everybody see how I got X plus 8? Yeah. Okay, so the theorem says that we need to multiply the whole times the outside. So the whole for the first one is X plus 8 times the outside, which is just 8. So I'm going to multiply this by 8. And I could put the 8 out back, or I could put it out front. Which would be better? Out front, so I can just distribute it, right? That's going to be equal to the whole thing of the bottom one, which we already calculated as 16, times the outside, which is 7. On the left, obviously, we have to distribute. So we are going to have 8x plus 64. And then with our calculator, we multiply 16 times 7, which is 112. Subtract the 64 from both sides. So 8x is 48, which is nice because 8 goes in there evenly. And we get x is equal to 6. All right? Most of the time, they just want you to solve for that x, but every once in a while, they'll ask you the whole lengths. They'll say, what is, okay, so we'll call this G to E. G to E, you would just add the 6 and the 8. So that would be 14 centimeters. This one we already figured out. That was like the first thing we did. All right, any questions on example number 2? All right, one more theorem. Well, let me move this up. The last theorem, or the third theorem, is called the secant tangent product theorem. So the secant tangent product theorem. Product means we're going to multiply again, so that's nice. But now we have two different kinds of segments. One's a secant, which we just saw in the last theorem, and the other one's a tangent. So let's draw it. All right, here's a circle. The secant looks like that, just like it did in the last theorem. Okay, so we're going to have this one passing through A, B, out here to C. Okay, that's our secant. The other one is just going to be a tangent. So it's going to go from C, and it's just going to touch the outside of the circle in one little spot right there. See how it's slightly different? This one's the secant. This one is the tangent. So you just need to be able to recognize which one's which. Okay? For this theorem, the secant is going to be the same. It's going to be the whole times the outside, just like we did in the second theorem. But for the tangent, you're going to take the length of the whole tangent and you're going to square it or multiply it by itself. Whatever its length is, if it's 7, you'll just go 7 times 7 or 7 squared, same thing, right? Okay. Last example, example number 3. It's our circle. Whoops. Shrink that down a little bit, sorry. There we go, now you can see them both. All right, so here is one that's passing through the circle to the outside. So that one's the what? The secant. We'll call that one L, J, M. The other one's going to go from L and just touch the side over here in one little spot. That's their tangent. Okay, so here are some measurements. From M to J is just 15 meters. And from J to L is 5 meters. And the piece that's missing, the length that we don't know, is that tangent over there. We'll call it X. Okay, so we're going to do the secant first. The secant, you do the whole times the outside. So we have to add these two together. What is 15 and 5? 20 meters, right? So we're going to do 20 times just the outside. So from J to L is 5. And then over here, we're going to do the tangent. Tangent's the one we don't know. We're going to put X there, but we need to multiply it by itself. So we're going to say X squared. Oh, I should have done it on the other side. Oh, well, we'll figure it out. All right, 20 times 5 is what? 100. Do we like 100? Yes. Yes, because when we take the square root, it's a perfect square, right? So X is 10. And that's all.